This is an example of a problem involving static equilibrium. A uniform beam is held up by two massless cables at an angle. Note that the problem is symmetric. It is possible to solve this problem using linear coordinates alone, but we are going to demonstrate this using torque instead. We set up our free body diagram notating the location of all forces. We choose the pivot point not at the center of mass, but rather at the location of one of the unknown forces. We must be careful to recalculate the radius and angle of each force. Of course, we must set up our coordinate systems around the pivot point, especially the angular coordinate. We set up a table of radius, force, and angle for each force that produces torque. Note that force A around our chosen pivot point does not provide torque and hence is not included. We set up expressions for the torques. We declare that the net torque is 0 and include the expressions. We solve for the unknown, insert the numbers with units, and calculate the answer. To solve for force A, we have a choice of multiple strategies. In this special case, we can just use symmetry arguments. Alternately, we can draw a new free body diagram using B as our pivot point and recalculate. Finally, in this special case, it is possible to solve using linear static equilibrium only.